Hello my friend, welcome to my channel Zip. I hope that you are well. In this video, let's answer the question how is JavaScript code executed. We already know that it happens in the engine, but let's dig deeper now. And let's start by supposing that our code was just finished compiling, and in the way that we learned in the last video. So the code is now ready to be executed. What happens then is that a so-called global execution context is created for the top-level code. And top-level code is basically code that is not inside any function. So again, in the beginning, only the code that is outside of function will be executed, and this makes sense, right? Functions should only be executed when they are called. And actually, we saw this happening already in our cat game project. So there we had an init function which initialized our entire project. But in order to actually initialize the game the first time that the page loaded, we need to call that function immediately in our top-level code. And so that's what I mean here. But anyway, we can also see what's top-level code is in this example here. So this name variable declaration is clearly top-level code, right? And therefore, it will be executed in the global execution context. Next, we have two functions, one expression and one declaration. So this will also be declared so that they can be called later. But the code inside the function will only be executed when the function are called. Okay? So we know that a global execution context is created for top-level code. But now, what exactly is an execution context? Well, an execution context is an abstract concept, but I define it basically as an environment in which a piece of JavaScript is executed. It is like a box that stores all the necessary information for some code to be executed, such as a local variable or argument passed into a function. So JavaScript code always runs inside an execution context. And to make this a bit more intuitive, let's imagine you order a pizza at a takeaway. So usually that pizza comes into a box, right? And it also comes with some other stuff that is necessary for you to eat pizza, such as cutlery or a receipt, so that you can actually pay for the pizza before eating it. So in this analogy, the pizza is a JavaScript code to be executed. And the box is, of course, the execution context for our pizza. And that's because eating the pizza happens inside the box, which is then the environment for eating pizza. The box also contains cutlery and the receipt, or fork, which are necessary to eat a pizza, or in other words, to execute the code. Okay? I hope that made sense. And to make the concept of the execution context a little bit more clear, now, in any JavaScript project, no matter how large it is, there is only ever one global execution context. It is always there as a default context, and it is where top-level code will execute. And speaking of execute, now that we have an environment where the top-level code can be executed, it finally is executed. And there is not a lot to say about the execution itself. It is just the computer CPU processing the machine code that it received. Okay? And once this first code, so the top level of code is finished, functions finally start to execute as well. And here is how that works. For each and every function call, a new execution context will be created containing all the information that is necessary to run exactly that function. And the same goes for method, of course, because they are simply function attached to object, remember. Anyway, all this execution context together make up the call stack that I mentioned before, but more on that in a second. Now, when all functions are done executing, the engine will basically keep waiting for callback functions to arrive so that it can execute this. For example, a callback function associated with a click event. So remember that it is the event loop who provide this new callback function, as we learned in the last video. Alright, so we know now what an execution context is, but don't really know what it is made of. So what's inside of it? And so let's find that out next. And the first thing that is in execution context is called a variable environment. In this environment, all our variable and function declaration are stored, and there is also a special argument object. This object contains, as the name says, all the arguments that were passed into the function that the current execution context belongs to. But remember, each function gets its own execution context as soon as the function is called. So basically, all the variables that are somehow declared inside the function will end up in its variable environment. However, a function can also access a variable outside of the function. And we have already seen that in Action Truth this course, especially in the project of the previous section. And this works because of something called the scope chain. And we will learn about scoping and the scope chain later in this section. But for now, what you need to know is that the scope chain basically consists of reference to variables that are located outside of the current function. And to keep track of the scope chain, it is stored in each execution context. Finally, each context also gets a special variable called the this keyword. And once more, there is a special video just about the this keyword later in the section. Okay? Now, the content of the execution context, so variable environment, scope chain, and this keyword is generated in so-called creation phase, which happens right before execution. And now, just one final but very important detail that we need to keep in mind is that execution context belonging to a row function do not get their own argument keyword, nor they get this keyword, okay? So basically, a row function does not have the argument object and this keyword. Instead, they can use the argument object and this keyword from their closed regular function parent. And this is an extremely important detail to remember about a row function, and we'll come back to it later. So these are the things that are necessary to run each function as well as the code in the top level. Now, behind the scenes, it's actually even more complex, but I think we are fine like this, aren't we? And now let's actually try to simulate the creation phase for this code example here. So, as you hopefully know by now, we will get one global execution context and one for each function. So one for the first function and one for the second function. In the global context, we have the name variable declaration, the first and the second function declaration, as well as the x variable declaration. For the function, the variable environment will literally contain all the code of a particular function. Now, the value of x is marked as unknown here because this value is the result of the first function that we didn't run yet. But we will simulate this in the next slide. Now, technically, none of this value actually become known during the creation phase, but only in the execution phase. So this is not 100% accurate here, but it is just to illustrate how this execution context work. Okay? So just keep that in mind. Anyway, Now, in the first function, we have the variable set to 1. Variable A set to 1 and the variable B, which once again require a function call in order to become now. Finally, the variable environment of the second function contain the C variable set to 2, and since this is a regular function, so not an arrow function, it is also has the argument object, and this object is an array which contains all the arguments that were passed into the function when it was called. In this case, as you can see, that's 7 and 9. Quite simple, right? Well, it is simple because this is an extremely small amount of code. But now imagine that are 100 of execution context of 100 of function. How will the engine keep track of the order in which function were called? And how it will know where it currently is in the execution? Well, that's where the call stack finally comes in. And remember that the call stack together with the memory heap make up the JavaScript engine itself. But what actually is the call stack? Well, it is basically a place where execution context gets stacked on top of each other in order to keep track of where we are in the program execution. So the execution context that is on the top of the stack is the one that is currently running. And when it's finished running, it will be removed from the stack and execution will go back to the previous execution context. And using the analogy from before, it is as if you bought pizza with some friend. Each friend has a pizza box and then you put the box on top of each other, forming a stack in order to keep track which pizza belongs to each friend. Now, all this sounds a bit abstract, doesn't it? And so to demonstrate how the call stack works, let's walk through this code example together so that can show you exactly what happens. So once the code is compiled, top level code will start execution. And then, as we learned in the beginning of the video, a global execution context will be created for the top level of the code, right? So this is where all the code outside of any function will be executed. And what happens with this execution context? That's right, it will be put in the call stack. And since this context is now at the top of the stack, it is the one where the code is currently being executed. So let's continue now with this execution. So here there is a simple variable declaration. And then the first and the second function are declared. So nothing fancy, but that's just how normal top level code gets executed. But then in the last line is where things start to get interesting. Here we declare the x variable with the value that is gonna be returned from calling the first function. And so let's actually call that function. Okay? Now what happens immediately when a function is called? Well, it gets its own execution context so that it can run the code that's inside its body. Perfect. And what happens to the context? Well, again, it puts in the call stack on top of the current context. And so it's now the new current execution context. Great. So let's continue. We have another variable declaration here, and this variable will of course be defined in the variable environment of the current execution context and not in the global context, right? Then, right in the next line, we have another function call. So let's call that function and move there. As I guess, as you guessed, as a new execution context was created right away for this second function, and once more it is pushed onto the top to the core stack and becomes a new act of the context. Now, what's important to note here is that the execution of the first function is now being paused. Okay? So again, we are running the second function now, and in the meantime, no other function is being executed. The first function stopped at this point, where the second function was called, and we will only continue as soon as the second function returns. And it has to work this way because remember, JavaScript has only one thread of execution, and so it can only do one thing at a time. Okay? Never forget that. Now, moving to the next line, we have return. We have return statement, meaning that the function we finished its execution. So what does that mean for the core stack? Well, it basically means that the function execution context will be popped off the stack, okay, and disappear from the computer memory. And at least that's what you need to know for now, because actually the popped of execution context may keep living in memory. But more about that later in the course. Anyway, what happens next is that the previous execution context will now be back to being the active execution context. And so let's also go back to where we are before in the code. And I hope that by now you start to see how the core stack really keeps track of the order of the execution here. Without the core stack, how would the engine know which function was being executed before? It wouldn't know where to go back to write. And that's the beauty of the core stack. It makes this process almost effortless. So I like to use the analogy of the core stack being like a map for the JavaScript engine, because the core stack ensures that the order of execution never gets lost, just like a map does, at least if you use it correctly. Alright, so we return from the second function, or back in the first function, where we have this calculation. And then finally, this first function also return, and so here the same as before happened. So the current execution context gets popped off the stack, and the previous context is now the current context where code is executed. In this case, we are back to the global execution context and the line of code where the first function was first called. Okay? So here, the return value is finally assigned to x, and the execution is finished. Now the program will now actually stay in this state for forever until it's eventually really finished. And that only happens like when we close the browser tab or the browser window. Only when the program is really finished, like this, is when the global execution context is also popped off the stack. And this is in a nutshell how the core stack works. So hopefully it makes sense now that we say that JavaScript code runs inside the core stack, and actually it is more accurate to say that code runs inside of execution context that are in the stack. But the general point is that the code runs in the core stack, which is of course true. Cool. Next up we will learn some more about the variable environment and how variables are created. To stay tuned for the next video, inshallah. So take care of us. Follow me in Instagram, faisal.cheku, to stay updated with this course. And subscribe to my channel, Faisal Azib. I tell you goodbye. Wassalamu alaikum wa barakatuh.